We've spent a good amount of time talking about hypothesis testing, doing hypothesis testing, T's, Wilcoxon's, rank sums, z-tests, and so on and so forth. But we need to take a little tangent and talk about mistakes or problems with hypothesis testing. And that is to say that sometimes when we go to make a decision, we make the wrong decision or we make an error. Now, I need to tell you a little bit about what that means. An error means that we make a mistake when we make our decision, but we never know that we've made a mistake. We just acknowledge that we might make a mistake. When completed, a significance test tells us a certain thing. It tells us the probability of our results if the null hypothesis were true. Now, if that probability is small, right, smaller than our significance level, usually 0.05, it's probable that the null hypothesis is false. It's not true, and we reject it. Our statistic that we're testing is what I'm calling our results. So the probability of our statistic under the conditions that the null hypothesis is true is our p-value. Now, sometimes we make the correct decision regarding the null, but sometimes we make mistakes because we're talking about probability. P is probability. P is something's likelihood of happening. And just because we say that something has a less than 0.05 chance doesn't mean that there's no chance at all. So we acknowledge that we can make errors in evaluating our probability and evaluating our hypothesis. However, we have to recognize that we could be wrong, and these are called errors. There are two types of errors in hypothesis testing. Okay, we call them type 1 and type 2 errors, but let's start over here in this matrix, this area of the matrix, and that is when we're completing a hypothesis test, we have one of two decisions. We either reject the null and accept the alternative, or we do not reject the null. We fail to reject the null, and we fail to accept the alternative. So these are the two things that we do. These are the decisions that we make. Now, in reality, there could be two states of affairs. We don't know which one of these is true. If we did, we wouldn't be doing a hypothesis test in the first case. In reality, if we knew everything, if we knew what was going on, if we were, omniscient being and knew the state of the world, then we could know, we could determine whether the null is true or the null is false. But we don't know whether the null is true or false. So, when we reject the null when it's true in reality, we've committed a type 1 error. When we fail to reject it and it's true, we've made the correct decision. When we've rejected the null when it's not true, we've made a correct decision, and when we fail to reject it when it's not true, we've actually committed another type of error. So type 1 error is when the null hypothesis is in reality correct, and we've rejected it in favor of the alternative. The probability of this error is alpha, our significance level. So we can also define alpha as our significance level, but also as the probability of rejecting a null hypothesis when it's true. It's the probability of committing a type 1 error. Now, if we say the probability of committing our type 1 error is 0.05, what we're saying is that's a pretty small chance. Type 2 errors are when the null hypothesis is false or incorrect, but we failed to reject it. Okay, it's not true, but we've failed to reject it. The probability of a type 2 error is signified by beta, and the power of a statistical test is 1 minus beta. We're going to be talking a lot about 1 minus beta and about power, and that is the probability of rejecting a false null hypothesis, or rejecting a null hypothesis when it's false. Now, to try to give you more, a better feeling on what alpha and beta are in type 1 errors and type 2 errors, consider you're on a jury, and you have to come to a decision about whether someone is guilty or innocent of some particular crime. Now, you don't know what the truth is. Evidence is going to be presented to you. There's going to be testimony from a particular expert. A witness is going to come in. Somebody's going to tell you about fingerprints or this, that, or the other thing. And then you're going to have to decide because the defense is also going to bring in witnesses that say that that's not his fingerprint, or that's not, he wasn't there, he was really sleeping, or whatever the case may be. We've all seen courtroom dramas, right? And we may have even been involved in some of this stuff. We don't know what is in reality true. One person says one thing, one person says another. We have to decide which one is more true. If we find an innocent man guilty, we've committed an error, a type 1 error. But if we find an innocent man innocent, we've made the correct decision. If we find a guilty man guilty, we've also made the correct decision. But if we find a guilty man innocent, we've committed this error. So I think finding a guilty man innocent is like a type 1 error, whereas finding a guilty man innocent is like a type 2 error. This error, we have to consider these two errors. Now they're related, they're not necessarily identical. The factors affect one and the other, but these are somewhat independent. The relationship between these two is actually pretty complex. But if we're concerned about putting an innocent man away, finding an innocent man guilty, then what we're going to do is probably allow more guilty men to go free. So we probably think that this is the most egregious error of putting an innocent man. In fact, our criminal court system says you are innocent until proven guilty. So we're not presuming guilt, we're presuming actually innocence in our legal court system. So I think it's the case that we are more concerned about a type 1 error than we are about a type 2 error. However, we can't be ignorant to that anymore. The relationship between alpha and beta is very complex, as I said a second ago. The probability of making a correct decision, though, if the null hypothesis is true, is 1 minus alpha. Okay? What if the null hypothesis is not true? Well, then the probability of rejecting a null when it's not true is 1 minus beta. So these things move together. In general, we do not set beta, but it is a direct outcome of our experiment. It can be determined. Beta is generally greater than alpha. One way to decrease beta is by increasing alpha. But we don't want to do that. Okay, let's unpack that. One way to decrease beta, to decrease the probability of a type 2 error, is by increasing alpha, the probability of a type 1 error. We don't want to do that. Yes, we don't want to do that. That's right. Because we don't want to increase the probability of a type 1 error in order to decrease the probability of a type 2 error. Or we want to decrease beta some other way. So let's reconsider alpha and beta. We want to minimize the chances of finding an innocent man guilty versus finding a guilty man innocent. We want to make sure that innocent men don't go to jail. Likewise, we should reduce the likelihood of finding an effect when there isn't one, making a type 1 error, versus decreasing the likelihood of missing an effect when there is one. In other words, we want to be sure that when we say that there's an effect, there's a difference, there is a change. When we reject the null hypothesis, we want to make sure that there's something there. Okay? If we reject the null hypothesis and it's actually true, we will be saying that something is true. There is a change, there is a difference, there is an effect when there isn't one. A type 1 error is saying that there is an effect when there isn't one. Okay, let me say that again. A type 1 error is saying there is a difference when there is no difference in reality. A type 2 error is saying we couldn't see the difference even though one might be there. So I think when you couch it in those terms, a type 1 error is a little bit more problematic than a type 2 error, and that's what we want to minimize. Okay, again, a type 1 error is saying there's an effect when there isn't an effect. A type 2 error is saying there's no effect when there is one. Missing an effect, if you will. And when we miss things in science, we're sort of throw up our hands and say, well, we didn't have enough evidence. We didn't do the experiment correctly, or we didn't have enough. We didn't have a large enough sample, or something like that. So we think that type 1 errors are a little bit more egregious than type 2 errors. That's it for this lecture. Carry on to the next one. We're going to be talking about